to True Projects. In this video, we are going to discuss about the project title, which is Semi-Supervised Deep Transfer Learning for Benign Malignant Diagnosis of Pulmonary Nodules in Chest CT Images. This project enhances the diagnosis of pulmonary nodules in the chest CT images. It acknowledges the critical relevance of correct nodule categorization in improving patient care and treatment results. This project provides unique ways to improve diagnostic skills by leveraging the potential of deep learning models, which are MobileNet and DenseNet. By doing so, it simplifies and improves the diagnosis process, benefiting both healthcare professionals and patients. The goal of the project is to use deep learning algorithms, notably MobileNet and DenseNet, to improve pulmonary nodule identification in chest CT scans. These algorithms help in the automation and improvement of nodule categorization, allowing healthcare practitioners to make more exact diagnosis. The efficiency of MobileNet and the feature-rich design of DenseNet both contribute to the robust and efficient model training. The project's goal is to use these algorithms to streamline the diagnosis process, eliminate human error, and ultimately deliver faster and more trustworthy evaluations of pulmonary nodules. This breakthrough will assist both radiologists and patients by speeding up diagnosis and boosting treatment results. These are the requirements needed to implement the project. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need Anaconda 3 and Visual Studio Community version. Here we have designed these modules in the flow of project to implement the project. First one is importing the packages. In this module, we will import all the necessary Python packages and libraries that are NumPy to work with the numerical data, Keras for deep learning, and TensorFlow for machine learning, Matplotlib for visualization. Next module is data exploration for CT COVID data. In this step, we load and explore the chest CT scan related to COVID-19 cases and perform data analysis to understand the characteristics of data and its structure. Third one is image processing. This module focuses on preparing the CT scan images for training and predicting. Here, we use these different modules, which are sub-modules. First one is using image data generator. In this module, we do the augmenting of the image to improve model generalization. Next one is rescaling the image. Here, we normalize the pixel values. Next one is shear transformation. Here, we apply shear transformations to the image for data augmentation. Next one is zooming the image. In this, we apply zoom to the images. Next one is horizontal flip. Here, we flip the images horizontally for augmentation. The last one is reshaping the image for pre-processing image to ensure we have the consistent dimensions. Coming to the fourth module, which is data extraction into training and validation sets. Splitting the data sets into training and validation set to train and evaluate the deep learning models. Next one is building the model. In this module, it involves creating different deep learning models for diagnosing pulmonary nodules. Here we have different algorithms. The first one is baseline model, which is backbone of ResNet 50. Here, ResNet 50, which is a sort of residual network within 50 layers, is a deep convolutional neural network architecture. It is characterized by skip connections that allow for training of very deep neural networks while mitigating the vanishing gradient problem. ResNet 50 serves as the baseline model in this project because of its proven effectiveness in image classification tasks. Its deep architecture helps in capturing intricate features in medical images, making it a strong candidate for diagnosing pulmonary nodules. Next one is baseline TL for backbone of Inception V3. Inception V3 is a convolutional neural network architecture known for its Inception modules, which utilize multiple filter sizes in parallel to capture feature at different scales. Transfer learning with Inception V3 is employed to leverage pre-trained weights on large image datasets. Fine-tuning of this module for specific tasks serves training time and benefiting from the feature extraction capabilities of Inception V3. Next one is baseline STDL backbone of Inception ResNet V3. STDL, which is semi-supervised deep learning transfer learning. Inception ResNet V2 combines the principles of both Inception and ResNet architecture, integrating Inception modules with residual connections. Inception ResNet V2 is used in semi-supervised deep transfer learning, where the model is fine-tuned on specific dataset. It leverages the strength of both Inception and ResNet, making it suitable for complex features, extraction and classification tasks. Next one is Malignant. Malignant is a lightweight convolutional neural network designed for mobile and embedded vision applications. It employs depth-wise separable convolutionals to reduce computation and memory requirements. Malignant is chosen for its efficiency, making it suitable for real-time image analysis. It is employed in this project to provide a quick and efficient option for diagnosing pulmonary nodules, especially when computing resources are limited. The last algorithm is DenseNet. DenseNet or Dense Convolutional Network is a neural network architecture that connects each layer to every other layer in feed-forward manner. It encourages feature reuse and facilitates the training of very deep networks. DenseNet is employed for its feature-rich architecture, which is particularly useful in tasks where intricate patterns and features need to be captured. It enhances the ability to detect and classify pulmonary nodules accurately. The next module is training and dumping the model. Here, this one. So training each model using the training data and then saving the trained models for future use. Next module is Flask Framework, localhost, sign up and sign in with SQLite. Setting up the Flask web application to provide a user interface for the pulmonary nodule diagnosis system and implementing the user authentication with SQLite 3 database for user registration and login. The 8th module is user uploads the image for analysis. In this module, we allow the users to upload their CT, chest images for analysis through web interface. Next one is 9th module, which is the given images process. In this, we have two things, which are using Keras image to array and the reshaping the image. After user image uploaded, pre-processing steps are applied to the user's uploaded image. Coming to user Keras image to array, converting the uploaded image to an array format will happen in this module. In reshaping the image module, it ensures that image has the required dimensions for the model input. Next module is train model is used for predicting the user data, utilizing the pre-trained deep learning model to make predictions on processed user image. Next module is predict with the model for outcome. In this module, running the user image through the selected deep learning model to predict whether the pulmonary module is benign or malignant. The last one is displaying the final outcome, presenting the prediction outcome to the user through Flask web interface indicating whether the detected nodule is benign or malignant. For execution of the project, we need to open the code folder which contains the source code files. This is the code folder of the project and this is the data folder. This contains the data sets which have different CT images. Here we have benign images, malignant images and normal images. These images will be used for training of the models. And this is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. And this is the templates folder. This folder contains all the HTML pages used in this project. It typically includes the files like index.html, about.html, etc., which represents different pages of the website. And this is the app.py file. This file contains the information related to the front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is the notebook.ipynb file. This is the Jupyter Notebook file which contains a combination of codes, graphs, and outputs all in one place. It allows user to write and execute code in individual cells, making it popular choice. And this is the signup.db file. This file is a database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. Now we need to open the Anaconda prompt. Here we need to use the cd command followed by the space and then pass the copied path. This command is used to change the current directory to the code folder's path, and click on enter. Here the directory is changed to the current folder. Now here we need to give the python space app.py file. This will compile the app.py file using the command which is python app.py in the command prompt, which is Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we'll click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is this one, and the port number, which is this one, unless configured differently. Now we will copy this link and paste it in any browser. I prefer Google Chrome. Here I need to paste the link and click on enter. Here, this is the home page of the project, which is redirected by the link, and this is displayed in the browser. And this is the front end built using the Flask framework. Now we need to click on the button login. Here we need to give the username and password. If you are registering newly, we need to click on sign up and then register. As I have already registered, I will directly sign in. So here I will be typing my username and password. Now I'll click on the button login. So it has redirected to the home page. Here we have benign malignant diagnosis in chest CT scan using transfer learning. Here we need to upload the image, then it will detect whether the image is benign or malignant. So we will click on the button choose file and select this particular image and click on open. And by clicking on the button upload, the image will be uploaded. So we will click on the button upload. So for this particular image, we have the prediction. Here we have the prediction. The patient is diagnosed as malignant based on the input image. Now we will try with the other image. So we will select this image and click on open and click on upload button. So for this image also, the patient is diagnosed as malignant based on the input image. Now we will try with the other image. So for this image, the patient is normal based on the input image, which means he has no disease. Now we will try with the other image. Now we'll choose the other image. I'll select this image and click on open and then click on upload. So here for this particular image, it has predicted that the patient is diagnosed as benign based on the input image. In this way, we can upload any other CT images and then the web application will predict whether the disease is malignant or benign or normal. So we will log out. Significant advances in the diagnosis of pulmonary nodules using the chest CT images. The project has successfully proved that the possibility for automated and extremely accurate nodule categorization by utilizing deep learning algorithms, notably MobileNet and DenseNet. This accomplishment simplifies the diagnostic procedure, lowering the possibility of human mistake and offering faster, more trustworthy results. As a result, increased diagnostic efficiency and treatment outcomes will benefit both healthcare professionals and patients. The effective deployment of these algorithms highlight the promise of artificial intelligence in improving medical diagnosis as well as the need for continuous research in this particular area. Thank you for watching this video.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.